Today in this video, I am going to discuss about Young's double slit experiment, which is done for the purpose of obtaining coherent waves and to find out the path difference between the two coherent waves. So here, how Young made this setup to obtain coherent waves from sources. So, it's clearly given in your NCERT book that if two sources were illuminated by two separate sodium lamps, the resultant coherent waves will not be coherent, they will be incoherent, because there will be some minute phase difference in the order of 10 to the power of minus 10. So, in this small interval of time, there will be some phase difference between the waves. So, automatically we know if there is some wave difference, if there is some phase difference between the waves, then they were not considered as coherent waves. They will become incoherent waves. So, what to do to obtain coherent waves? Young experimented. Young discussed a lot within him, and in the meanwhile he arrived a setup, and the setup is here I have drawn in the board. So can we go and see the setup, how Young made to obtain the coherent waves? Yes, if you see here, there is a source. The source is of sodium vapor lamp. The source here refers to sodium vapor lamp, and the light from the sodium vapor lamp is made to fall on this cardboard. Okay? Is made here, they have kept a cardboard. Can you see here that they have drawn in orange color line? So it is the cardboard. So here in this cardboard, I made two slits. Slit here refers to small cuts. Okay? So two small cuts like S1 and S2 have been formed by cutting two small pieces of the cardboard, and these two slits were illuminated by the same source. These two slits S1 and S2 were illuminated from the same light source, that is from the same sodium vapor lamp. Okay? So, when light from the sodium vapor lamp fall on these two slits, we can get two waves. Am I right? Two waves will be formed. Will there be any phase difference between the two waves? No. Very good. So, since the two slits were illuminated by the same sodium vapor lamp, what will happen? There will be no phase difference. Otherwise, there will be a constant phase difference between the two waves. These are conditions of coherent waves. Do you know the condition of coherent waves? Yes. There are four conditions for satisfying by a wave to be coherent. So the very first condition is a light wave, two waves should travel the same distance at the same time. Repeating again, two waves like this, two waves should travel the same distance at the same time. And the second condition is they should have same wavelength. And the third condition is they should have same frequency. Okay? And the very fourth condition is what we are discussed. Young worked out a lot about this condition, that is there should be a constant phase difference between the two waves. So these are all the conditions for coherent waves, and since these two slits were illuminated by the sodium vapor lamp, so these waves achieved the condition discussed by that should be satisfied for coherent waves. So what do you mean by this? Here, this is your screen. This a large yellow color, long yellow color line is your screen. It represents your screen. And if you look here, we are taking an arbitrary point P. Here, we are considering an arbitrary point P. So, now we are this waves from S1 reaching the point P, what will happen? When they are reaching the point P, it will travel a distance like this, and the wave from S2 will take the path like this. Am I right? It will move from S2 to P. The wave from S2 to P will reach like that. Okay? So, the distance between the two slits is given as small d, and the distance between the slit and the screen is given as small d. Okay? And if you see here, this is your central axis that is moving from the main source to the screen. That is your central axis, and the central axis, the point at the central axis, center of the central axis, I am considering it as O. Okay? The point at the central axis that joins on the screen, that point is considered as O. Okay? So the distance between O and any arbitrary point P is considered as S. And for the main reason for this Young's double slit experiment is to find out the path difference between the two waves. Path difference is denoted by del x. Path difference is denoted by del x. So, for finding out the path difference, we are considering two more points named A and B. Okay? Where if you join S1 to the screen, you will be getting the point A, and if you are joining S2 to B, you will be getting the point B. Okay? S2 to the screen, you will be getting B. So, this is the experimental setup of Young's double slit experiment, where you can see main force illuminated by two slits, and these two slits now behave like two sources that produce coherent waves. Here I discussed the condition for coherent waves, that the coherent waves should travel the same distance at the same time, they should have same wavelength, they should have same frequency, and they should move with constant phase difference phi. Let me calculate the path difference in our next video. Thank you.